The bubble sort is, as I said, a very simple sort that um, has this basically three-step algorithm. So it goes through each space, if you will, in the list. So when you have an array, if I have an array of 10 items, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's going to start at that point looping at the first index and then have an inner loop that loops at the last index. And it's going to go backwards from the last index, moving down towards the current space where it takes the lowest value and of the two, starting at the back, and it bubbles it up. You still. So if I have, the last item is a 0 and there's no negative numbers, then that 0 is going to move from the back item all the way to the front. So by the time each loop finishes, the smallest item ends up front. Then the second smallest item ends up second. The third item ends up third. But it does bubble up every other smaller value as it goes. So theoretically, it gets faster and faster and faster as it goes. So that's the notion behind the bubble sort, is you essentially start at the first one and work from the back. And so if you had a list of people, I want to find the shortest person. I start at the beginning of the line, then I go to the back of the line and switch out every other person until the shortest person ends up all the way up front. But only if it needs to be swapped. So let's take a look at that in action here. That's really the best way to see the bubble sort. So we're going to be sorting this string sorting fun a lot here. But as I said, the first index starts at the beginning of the list, of the array, and the second index starts at the end of the array. And so I look at the n and the u, in this case, and the n is less than the u, so I swap them. And then the index goes smaller, and I look at the n and the f. Well, the f is lower than the n, so I leave it alone. The f and the g, well, the f is smaller, so I swap them. Now I just compare the f and the n, and look, I swap them. And I'm going to keep pushing the f down because it's the first one, but I keep moving j down by 1 and comparing f and t, well, smaller, so I swap it. And so the f essentially bubbles up until it ends up at the top of the list. And so once I've either arrived at the top of the list or have nothing else to sort, everything gets pushed up again. So the I index, the outer loop, goes up to number 1. We started at 0, went up to number 1. The j goes back to the last item in the list. And again, I compare the n and the u, doesn't change anything. The n and the g doesn't change anything. The g in the next n, though, g gets pushed down, and now g again becomes the new thing bubbled up. It's going to be less than every single one of them, so everything gets bubbled up until the g becomes the second one, and then it continues on. Again, I goes up to number 3, j goes back list, and I'm not going to keep driving through this because the next thing happens, but if you kind of predicted first ahead, I is the next one down there. So u and n is going to change, but I is going to bubble all the way up to the top. And then after that, the n is going to bubble all the way. And then the other end is going to bubble all the way, and so on and so forth. So it's a very thorough, very safe approach to this. It also is very slow because I have to touch every single item, possibly more than certainly more than once, but every single time through. And so what we're going to see, this is what's called an n squared algorithm. We have to do everything twice at least inside of it. We'll worry about that after we coded this stuff a little bit, but it's a very slow algorithm. So if we consider the analysis of this, then because it's touching every space every time, it means I have a whole lot of comparisons that's going on here. It has a tiny little bit of an advantage if the list is already sorted. It works a little bit faster, and there's no real big penalty for if the list is backwards. Now that's something we're going to talk about a lot going through here, is if you think about the algorithm, what would happen, if we step back here, if this list was already in sorting order? Well, in this case, if we go to our algorithm, we would still go through every single item every single time. We wouldn't actually change much at all, except for we'd never be moving anything. We'd still be checking, we'd just go along. So it saves the effort that we don't swap values ever. We have 3 or 4 lines of code that we can skip, but it still touches everything as we go along. And this is something that's important to pay attention, because when we get the advanced lists, we actually have some of the algorithms that will completely blow up, and you can actually end up getting exceptions and killing the program if it's not if it's already coming in sorted order. But this one, yeah, whether it's forward, backwards, it all kind of works the same, slow. across the board. It works slow. All right, so the bubble sort, pretty straightforward. My recommendation to you is, if you have the ability, go start coding this right now. Start playing with it. There's an algorithm in your book for sure. You can find them online as well if you don't like the one in the book. But code this up just to get a feel for the environment, how to play with it, and make it all work and go from there.